Welcome, my name is Dr. Dan Wedding, and this is Dr. Wedding, PLC01. Introduction to PLCs. There are many different manufacturers of PLCs, such as Allen Bradley, Siemens, Honeywell, Mitsubishi Electric, and many others. Each one of these manufacturers has many different families and varieties of controllers. This video series will use the RS Logix 5000 family of PLC controllers by Rockwell Automation to teach you the basics of PLC programming. If you are confused about the difference between RS Logix 5000 and Studio 5000 software, you are not alone. Simply put, RS Logix 5000 is version 20 and before, and Studio 5000 is version 21 forward. They are similar, but not identical. Independent of manufacturer and controller family, you will need to decide on a physical configuration. There are two physical types of PLCs you can purchase: modular and fixed. There are advantages and disadvantages for both types. Which one you choose will depend on your needs. A modular system has each part purchased separately and is assembled on site. You start with a backplane. A backplane is a printed circuit board with plugs on it. It is shown in green in this illustration. You then purchase the parts you need and plug them into the backplane. On the far left is a power supply. Next is the central processing unit. It is the brain of the device. This is followed by a 16-port input card, and then by a 16-port output card. The advantages of this type of system is it can be configured in many different ways depending upon your needs. And if a part is damaged, only the broken module needs to be replaced. The disadvantage is that they cost more than a fixed system. A fixed system has all of the parts integrated into a single module. This type of system can't be altered or customized. On this example, there is a central processing unit on the far left. Then there is a 16-port input card and a 16-port output card. On the right side of the module is an analog card, a high-speed counter, and a device net port. The advantages of this type of system is it is cheaper than a modular system, and it works right out of the box with very little work. The disadvantage is that if a part is damaged, the entire module needs to be replaced. You may be wondering what a PLC is used for and how it is wired up. A PLC will be connected to objects called field devices. Field devices can be broken into two categories: inputs and outputs. Inputs are devices that can be changed by a person or the environment, such as toggle switches, push buttons, pressure switches, float switches, temperature switches, proximity switches, and limit switches, just to name a few. These input switches may be normally open, meaning they are open at rest, and when a force acts on them, they will close and complete the circuit. The input switches may also be normally closed, meaning they are connected at rest, and when a force acts on them, they break and open the circuit. A field device can also be an output. Outputs are turned on or off by the PLC. A lamp and a motor are two examples of an output. There are more outputs that are not shown here, such as control valves, assembly line conveyor belts, gas furnaces, and water pumps. Connecting a field device to a PLC is very easy. The input and output cards have terminals attached to them. These terminals are often hidden behind a small plastic door. The input field devices are connected to the input card terminals, and the output field devices are connected to the output card terminals. The order you attach the devices to the cards does not matter because the PLC can be configured to match how it was wired up. It is very important to understand that the inputs are not directly connected to the outputs. The PLC program will monitor the state of the inputs and then decide if an output should be turned on or off. Because the inputs and outputs are not directly connected to each other, you can have a 480-volt, three-phase motor turned on and off with a low-voltage momentary switch. Because the PLC program is monitoring the switch states, you can make a change without rewiring the system. If you later decide that the motor needs to be controlled by a pressure switch on port 5, you can simply change the port number the PLC program is monitoring. This example is given to demonstrate how a PLC works in conjunction with the field devices to control a process. In this example, a PLC will be used to keep a tank of water filled on a production line. The tank has two float switches attached to it, the upper switch with green control wires and the lower switch with red control wires. Above the tank is a water pipe with a motorized ball valve attached to it. The motor is controlled by the purple control wires. The PLC program will monitor the two input switches. When the lower switch opens up, the water is at its low point. The PLC will then send a signal to the motorized ball valve so the water can start to fill the tank. When the upper float switch closes, the water is at its high point. The PLC will then send a signal to the motorized ball valve to turn off the water. This very simple example demonstrates how industrial processes can be automated with a PLC. In a lab setting, we don't have access to water tanks, conveyor belts, three-phase motors, temperature sensors, and all of the other field devices you may find on a production floor. Instead, I will be using this lab station in this series of videos. It does not matter if I use lamps instead of motors and simple toggle switches instead of complex sensors. The PLC treats all of the inputs the same and it treats all of the outputs the same. So flipping a toggle switch is no different than a water level switch opening up. And lighting a lamp is no different than turning on a motor that is controlling a ball valve. This lab station is a fixed PLC that has 16 inputs and 16 outputs. Next to the PLC is a power supply and a network switch. There are 8 lamps tied to the first 8 outputs. They are numbered 0 through 7, where the top red lamps are outputs 0 through 3 and the bottom lower green lamps are outputs 4 through 7. There are also 8 toggle switches connected to the first 8 inputs of the PLC. They are numbered 0 through 7, where the top row of switches are inputs 0 through 3 and the bottom row of switches are inputs 4 through 7. This lab station also has a human-machine interface, called an HMI. This is a touch screen that can be used to create buttons, checkboxes, and switches. It can also display images and process information to the user. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This will help introduce these videos to other students who might be struggling in their PLC class.